Multitasking is an essential part of today's working environments, whether intentionally or involuntarily through a plethora of devices and communication channels. Multimodal interactions based on natural behavior are a promising solution for concurrent multitasking scenarios. Prominent examples as demanding scenarios are flight and train traffic controlling or medical interventions. To investigate the idea of multimodal input, we picked interventional radiology as a concrete example, because during the course of an intervention, interaction with medical images is required simultaneously to the high-priority task of instrument handling. During a catheter intervention, instruments must be held and guided to the correct position in the body. In order to navigate the instrument to the targeted pathological structures to be treated, the radiologist relies on real-time image data. Current angiography systems offer the possibility to interact intraoperatively with these image data on a monitor. Within the system, medical image datasets or viewports on the screen can be selected, functions executed, or modes changed by a control panel with joysticks, button, touch displays, and additional foot pedals. The data can be manipulated in 1 or 2 dimensions using these control elements. Even though a medical scenario served as an exemplary scenario in this work, the tasks were abstracted in a way that no expert knowledge is required. The manual movements of a radiologist are to be imitated using the example of a guidance of a catheter in a vascular structure during an intervention. We simplified this task to forwards and backwards movements and created a prototypical input device. An abstract visualization in form of a horizontal bar displays the user input and a target marker. The interaction steps during the diagnosis or treatment of an arteriovenous malformation served as the foundation for our secondary interaction task. It is difficult to precisely recognize details, such as the position of the catheter within such images. To get as much out of the images as possible, the radiologist should be able to zoom and pan into the region of interest. For image manipulation, we focused on panning and zooming, as it corresponds to one-dimensional and two-dimensional input and therefore can be transferred to a wide range of HCI tasks. To allow pointing without using the hands or fingers, head movements are used. Based on our observations during a radiological intervention, leaning closer to a display indicated the need to see more detail. Therefore, leaning to the front is used for zooming in, while leaning back zooms out. The zoom level is directly mapped to the leaning angle of the user. The position of the upper body is set as 100% magnification when the desired view is selected using one of the selection methods. Lowering and lifting the eyebrows is used for zooming in a similar fashion. Lowering starts zooming in, while raising the eyebrows zooms out. During both methods, panning can be performed simultaneously by head pointing. Confirmation of the element to be pointed at is done via voice commands and head gestures.
Select. Select. Exit.
Confirmation of a selection with head gestures is done with a nod. Similar to voice commands, the cursor has to stay over the object to be selected while performing the gesture. Shaking the head deselects the current object. Both head gestures are further used for activation and deactivation. Our results pave the way towards efficient, natural, hands-free interaction in a challenging multitasking environment. Taking a closer look at continuous manipulation methods for hands-free zooming reveals that full body movement performs significantly better than facial expressions, moving the eyebrows, in terms of task completion time. We found a main effect within our sample between the selection method and the time spent outside the target range for the primary task, indicating that head gestures may influence the primary task less than voice commands. As a summary, gestures should connect to natural movements because unusual movements, such as moving the eyebrows, are less precise and exhausting.